Okay, so let's expand on this idea. Again, we have limits two different ways in this area right now. We had graphically, looking at a graph, what's happening, and using a table by plugging in numbers and seeing what's happened. So those examples are going to be pointed out in the next two examples. The first one, example one here, says finding a limit. This is a graphical example. It says find the limit of the limit is x approaches 1 of 2x plus 4. If you notice here, we have a y-intercept of the point 0, 4. And if you see, I go up 2 to the right 1 to find the next point, or down 2 and to the left 1 to find the next point. So that seems like the proper graph to me. This is the graph of y equals 2x plus 4. So that's our graph, okay? So what the heck is the question asking? This is saying, as x approaches 1, what is y? What does y approach? Okay, that's really what that's asking. So let's look at it. Here's x equals 1 right here. Here's the point in consideration, but I do not care what happens at that point. So let's look at it from the left. As I approach it from the left, this is what it would look like. I'm going to put my laser pointer on there and I'm going to approach it. Notice what's my y value approaching. What's the y value approaching? So my x value is approaching 1. My y value is approaching, well, it looks like the y value is approaching 6. Same thing from the right. As I approach x from the right, x equals 1 from the right, what's my y value approaching? Look at my laser pointer. It looks like my y value is decreasing to the value of 6. So what we've just shown is we know the y value is approaching 6, so my final answer would be 6. We just determined the limit as x approaches 1 of 2x plus 4, the function 2x plus 4 would be 6. As x approaches 1, my y value approaches 6. So that's graphically, all you're doing is looking at what's the y value approach. Now I do want to remind you, it doesn't matter what's happening at that point, it's only near the point, and we are going to see different things where maybe from the left and from the right don't agree and talk about what does that actually mean in terms of a limit. But now let's go on to finding a limit using a table. This was done on the previous page. All we have to do is plug the x values into the function and get what the y values are. I created a handout that's called something like using a table with a TI-30XS. It should be posted right before this section in Canvas. I want you to go ahead and take a look at that handout. It's going to tell you how to use the table feature on your calculator, which you're going to use for every single one of these problems in this section and many more problems throughout the semester. So I want you to get really, really comfortable using the table feature on your TI-30XS multi-view. So what would I do for this problem? The first thing that I'd do is I would hit the table button on my calculator. I would clear out anything that's on there. And then I would type in 2x plus 4 and hit enter. Now what I'm going to do is, it doesn't matter where you start. It doesn't matter what the step size is because we don't care about that. But what I want to make sure you select on your calculator is the Ask X option. And then click OK. At this point in time, you're able to type in 0.9, 0.99, 0.999. Just hit enter every single one of those, okay? And I do want you to notice on this as we go, so the goal is what happens when x equals 1, but I don't care about what happens at that point, only near the point. So what I want you to notice is as we come from the left, do you notice when we plug in 0.9, 0.99, 0.999, we're getting mathematically closer and closer to the number 1. So let's go ahead and fill in the values that our calculator is giving us. Use your table feature now. When I plug in 0.9, I got 5.8. When I plugged in 0.99, I got 5.98. And when I plugged in 0.999, I got 5.998. Okay? So what I'm going to notice is as I come from the left, look at those values. 5.8, 5.98, 5.998. What numbers does that seem to be approaching? So from the left, the left, that's a T there, y value or the function value approaches the number 6. Let's do the exact same thing from the right of 1. So I'm going to start off with the value of 1.1. I'm going to then plug in 1.01 and 1.001. So at this point in your calculator in that chart, you're looking at the table. Just click the up arrow twice. Now type in the new numbers. Start with 1.1. then plug in 1.01, then plug in 1.001. So when I plug in 1.1, I got a value of 6.2. 1.01, I got 6.02. 1.001, I got 6.002. So what do I notice is as I come from the right of 1.1, 6.2, 6.02, 6.002, what number is that approaching? So I'm going to say from the right, I notice that my function value approaches the number 6. And here's the key that we need to note every single time. These are approaching the exact same y value. They're both approaching 6. Because they're both approaching 6, we know the limit exists, and the answer is that number. Let me do that not as a highlighter, as a pin, the number 6. So the answer in this case would be 6. As x approaches 1 from both the left and the right, the y value approaches 6. Okay? So that should give you a good idea of what's going on. This next example is the actual example that I put in the handout. What I want you to notice here, and you can notice on the previous problem, if you plugged in a 1, you actually did get the number 6, but I don't care what happens at that point, only near the point. The only reason I'm emphasizing that is because now we're looking at the limit as x approaches 1 of the function x squared minus 1 all over x minus 1. And notice if I plug in the number 1, I would have 1 squared minus 1, which is 0, and 1 minus 1, which is 0. So I'd have 0 over 0. If I tried plugging in 1, it would be 0 over 0, which is called indeterminate form, which is undefined. So that tells us that the function value at that point 1 is undefined. It's not clear what the value is. It is not defined. It's division by 0. So this is a very important thing to understand the difference between just plugging in a number, which we could do on the previous problem, versus here we truly can't plug in the number. We have to analyze what happens near the point, not at that point. So I can't stress that enough. It's what a limit is what happens near the point, not at the point. At the point it's undefined. Let's look at what happens near the point. So I'm going to use my table feature on my calculator. Again, I'm going to hit table, clear out the function that's there, type in the fraction using the n over d button to enter a fraction, type in x squared minus 1 on top, x minus 1 on bottom, go ahead and hit enter. Once you've done that, you're going to see the start. Doesn't matter where you start. Mine's usually default set to -5. The step, doesn't matter what your step is. My usual default is 1. But what's really important is that you select Ask X and then hit the OK button. So Ask X and OK. Now you're going to type in those numbers 0.9, 0.99, and 0.999. Okay? And if you look in your calculator, most likely it's going to give your answer in the fraction form. If your answer is in the fraction form, there's a little double arrow right above enter, I believe. A little double arrow button that looks something like this. That button's going to be key to you this semester. Anytime you have a fraction and you want it in a decimal, hit that little double arrow button, the opposite arrows. That's going to change it from a fraction to a decimal. And likewise, if you have an answer that's in decimal form that you want as a fraction, hit that button and it'll change it to a fraction. So that little double arrow button goes back and forth between fractions and decimals. So when you do this, you're going to get y values that are fractions. That's okay. Just highlight the y value, move your arrows until you're over that y value, hit that double arrow button, and it'll tell you what the decimal value is. So the decimal value on the first one, when I plugged in 0.9, I got 1.9. When I plugged in 0.99, I got 1.99. When I plugged in 0.999 into the function, I got 1.999. So what do I want you to notice? Well, our x values approached 1 from the left. We were smaller than 1, and we got closer and closer to 1. Look what's happening to the y values. 1.9, 1.99, 1.999. So, as x approaches 1 from the left, my function value approaches the number, well, it looks like it's getting closer and closer to 2. Let's look at this way. Let's go the other direction. You already have everything entered in your calculator, so just hit the up arrow until you get to the first x value that you can enter and just start retyping them. First plug in 1.1, 1.01, and then 1.001. So when I plugged in 1.1, I got the number 2.1. When I plugged in 1.01, I got 2.01. When I plugged in 1.001, I got 2.001. So again, my x value got closer and closer to the number 1. So as x approaches 1 from the right, I notice that my function value, 2.1, 2.01, 2.001, my function value is approaching 2. So since the left and the right are approaching the same number, which is 2, we know the limit exists and the limit is 2. The limit exists and the limit is 2. Okay. So, graphically, we could have done the exact same thing. If we came in from the left, you would have noticed my y value is approaching the value of 2. If we came in from the right, we would notice my y value again is approaching the number 2. So that would have given us the answer. Notice graphically or algebraically, when we plugged in the number, we got 0 over 0, which was indeterminate. Graphically, that's represented by just an open circle. An open circle means it's not defined at that point. So that's how you would solve this problem both algebraically and graphically, or using a table and graphically right there.